Ashtin, and we're the Classy Chemists.
Today we're going to teach you how to
determine limiting reagents.
Hi, I'm going to help you with number 59. If 40 grams of molten iron 2 oxide reacts with 10 grams of magnesium, what is the mass of iron produced? The first step is to look at our equation. We are lucky with this number because the equation is already balanced. From here, what we're going to do is find the mass of iron produced, both from molten iron oxide and from magnesium. So to start, the first one that we're going to do is the iron oxide, and we're given 40 grams. The first step is to convert the 40 grams of iron oxide into moles of iron oxide. This is simply a bridge to ultimately get to the mass of iron produced. We're going to convert 40 grams of iron oxide into 1 mole of iron oxide with the molar mass. The molar mass of iron oxide is 71.85 grams. And we get that from our periodic table. Both the mass of iron and the mass of oxygen combined is 71.85. And that's equivalent to 1 mole of iron oxide. The next step is to get 1 mole of iron by itself without the oxide. We're going to do that by putting 1 mole of iron oxide in the denominator here so that we can cancel out the iron oxide. We should also cancel out the iron oxide here and here. 1 mole of iron oxide is equivalent to 1 mole of iron. We get that simply from our balanced equation here and here. It's important to note in this step that that ratio will not always be 1-to-1. We can go back now and cancel out the iron oxide and the iron oxide. The next step is going to be converting iron to grams, trying to get the mass of the iron produced. So we're going to convert from 1 mole of iron into the grams of iron. In that step, we'll need to cancel out the moles of iron. So we're going to put 1 mole of iron in the denominator. And 1 mole of iron is equivalent to 55.85 grams of iron, which was determined from the periodic table because it's the mass of iron. So we can now go ahead and cancel out the 1 mole of iron and the 1 mole of iron, and we are left with 40 grams times 55.85 grams divided by 71.85. That gives us 31.093 grams of iron produced. Because we started with 3 significant figures in the beginning, we should also answer the question with 3 significant figures. So we're going to go ahead and make this into 31.1 grams of iron. Now we have the mass of iron produced from the molten iron oxide. Now we're halfway there. From here, we're going to do the same equation, but now with the magnesium. So we'll take the 10 grams of magnesium that we're given, and our first step is to convert it into 1 mole of magnesium. One mole of magnesium is equivalent to 24.31 grams of magnesium, which is the molar mass of magnesium and is determined from your periodic table. We're now able to cancel out the grams of magnesium and the grams of magnesium. From here, we want to convert 1 mole of magnesium into 1 mole of iron. Again, this is simply a bridge to ultimately get to the mass of iron produced. In order to convert it into 1 mole of iron, we need to put 1 mole of magnesium in the denominator to be able to cancel out the moles of magnesium. Again, 1 mole of iron and 1 mole of magnesium is taken from the balanced equation, and this ratio will not always be 1 to 1. You can go ahead and cancel out the moles of magnesium and the moles of magnesium. Now we want to convert 1 mole of iron into the grams of iron, which will ultimately give us the mass of iron produced. In order to be able to convert it into grams, again, we need to cancel out this mole of iron. So we put 1 mole of iron in the denominator. 1 mole of iron is equivalent to 55.85 grams of iron, the molar mass. Which was determined from the periodic table. We can now go ahead and cancel out this 1 mole of iron and 1 mole of iron, and we are left with 10 grams times 55.85 grams divided by 24.31, which gives us 22.97 grams of iron. Again, because we began with 3 significant figures, we want to end the problem with the answer in 3 significant figures. So we're going to go ahead and make this 22.97 into 23.0 grams of iron. As you can see here, the mass of iron produced is significantly greater when it's coming from the iron oxide as opposed to the magnesium. So this makes the magnesium our limiting reagent, because with 10 grams of magnesium, we're only able to produce 23 grams of iron. So here, the magnesium for number 59 is the limiting reagent. Thank you and good luck.
Number 69 from your textbook to help you do the limiting reagent problem. So for us we have, if 70 milliliters of nitrogen gas reacts with 45 milliliters of oxygen gas, what is the volume of N2O3 produced? And we also want to know if our gases are the same temperature and pressures, because that can make a difference in your problem. So for our problem today, we know that the gases temperature and pressure are all the same. So we're going to go ahead and look at our given equation that we have. As you can see, it's not balanced. So we need to balance our equation. To balance equations, you want to pick out the most complicated looking one in the formula. So I'm going to say that this is the most complicated, so this is where we're going to start. I like to do is I like to write down what we have of each of the elements so that we can balance easier. So we know that we have 2 nitrogens on this side. We have 2 oxygens on this side. We also have 2 nitrogens on this side, but we have 3 oxygens on this side. So you can see, again, we're not balanced. So between these 2 oxygens, you want to pick the most common number that they both can go into. So for these ones, 6. So we're going to multiply by 2 to make this oxygen become 6. And I like to draw these little arrows because sometimes it helps. So know that when you multiply one, you have to multiply the other. So we now have 4 nitrogens on this side. So because we now have 4 on this side, we're now balanced on this side. So we need to make sure that we balance this out. So I'm going to go ahead and balance out the ends, and then I'll go to the O on this side. So we need to multiply this by 2 to make this become 4. So now we are balanced on both sides. Now we need to finish balancing our oxygen. To make this 2 become a 6, like the other side, we need to multiply by 3. So now we have our balanced equation. I'm going to go ahead and write it right underneath here so that we can make it easier. Okay, so now that we have our balanced equation, we can go ahead and go through the process of figuring out how much N's and how many O's can make N2O3. So we're first going to start off with our N2. We see that we have 70 milliliters of nitrogen gas, so we're going to go ahead and write that down. And we're going to need to figure out how many of those and how to convert it to N2O3. So, to get rid of this one so that we can get to this one, we're going to have to put this on the bottom. So, we need to know how many of these can make those. So, you can see from our balanced equation, we have 2. So, we have 2 milliliters of N2 on the bottom. And we need to know how many of those makes N2O3. So from our balanced equation, we can see that it also makes 2. So we're going to put 2 milliliters of N2O3. So we can go ahead and cancel these out just like basic algebra, and then you can go ahead and do the math all the way across the board. So we're going to have 140 milliliters of N2O3 over 2. You're going to go ahead and simplify this, and we're going to get 70 milliliters of N2O3. So that's our first one. We now need to do another one for oxygen. So we're going to go ahead and do that. We know from our equation that we have 45 milliliters of oxygen. So I'm going to go ahead and write that down. Okay. Just like the problem above, we're going to need to get rid of these so we can convert it to N2O3. So we know from our balanced equation that we have 3 O2s. So I'm going to write 3 milliliters of O2 in the denominator. We're then going to see how many of these are N2s on our equation. So we have 2, just like the top. So we have 2. Okay, we're going to cancel these out, just like I said before, basic algebra, and then you're going to go ahead and multiply across. So 45 times 2 is 90 milliliters of N2O3, and then we have 3 on the bottom. You're going to go ahead and simplify this down, and you're going to come up with 30 milliliters of N2O3. So, for our limiting reagent, you're going to look at which one stops us from producing more of something else. So, we can see from our equation that our limiting reagent is going to be the oxygen because it can only produce 30 mLs of N2O3.
Number 65, if 1 gram of aluminum hydroxide reacts with 3 grams of sulfuric acid, what is the mass of water produced? So again, we're looking for a limiting reagent, but before we can even start, we need to make sure that the chemical equation our book gave us is correct, which it's not. Start with the most complicated compound, and you'll see that we have 3 sulfates, but on the left we only have 1, so we need to put a coefficient of 3 in front. So now we're evenly matched. Next, we have 2 aluminum on the right, so we need to put 2 aluminum on the left. Now let's look at how many oxygen we have. We have 3 oxygen times 2, our coefficient that we just put, which gives us 6 oxygen. And we only have 1 over here, so we need to put the coefficient of 6. Now let's just make sure our hydrogens are evenly balanced, and we have 12 hydrogen on the right. Over here we have 6 hydrogen plus 6 hydrogen, so we have 12 hydrogen on each side. So we're ready to start our problem. We're given that we have 1 gram of aluminum hydroxide. And our first step is going to be computing our molar mass. And we determine the molar mass of aluminum hydroxide by looking at the periodic table and finding the atomic weight for each element. We have 1 atom of aluminum, so it's going to be 26.98 grams. We have 3 atoms of oxygen, so we have to do 3 times 16 grams, and we have 3 atoms of hydrogen as well, times 1.01 gives us 78.01 grams. Now I knew to put 7801.01 grams as the denominator because we want them to cancel out. And for the numerator, I just said that we computed the molar mass, so the unit factor is 1 mole of AlOH3 is 78.01 grams of aluminum hydroxide. So now we want to convert into moles of the water so we can calculate the grams eventually. And we're going to do that by comparing the ratio of moles of aluminum hydroxide to our moles of water. We see here that we have 2 moles of aluminum hydroxide. And up top, once again, we want these to cancel out, so we know that this needs to be as the numerator. We see that we have 6 moles of water. And our final step is going to be converting from moles into grams of water. So once more, we want to put our moles, 1 mole of H2O goes on the denominator, so we can ultimately cancel those out. And we're going to put the molar mass calculated of water as the numerator. And once again, I calculate the molar mass of water by taking our 2 hydrogen atoms and multiplying it by the weight of hydrogen in the atomic or the periodic table. 1 oxygen at 16 gives us, when we add these together, gives us 02 grams of water. So our last step is going to be finding out how many grams of water we have with 1 gram of aluminum hydroxide. So from here on out, it's all math. So 1 gram divided by 78.0 grams, multiply it by 6 moles, divide it by 2, multiply it by 18.02, and that gives us 6.92. Which gives us 0.6929, but we have 3 significant figures to start off with, so we're going to round that 9 and give us 0.693 grams of water is produced from 1 gram of aluminum hydroxide. We're only halfway done. We need to calculate how much 3 grams of sulfuric acid will produce of water. So we're just going to repeat the same steps with different numbers. So 3 grams of sulfuric acid. We're going to calculate its molar mass, which one more time you have to add all the atoms of the compound together. So 2 hydrogen times 1.01, 1 sulfur at 32.07 grams, and 4 waters at 16 gives us a total of 98.09 grams. Of sulfuric acid. Next, we want to go into moles of sulfuric acid. So we know that the molar mass is 1 mole of sulfuric acid is 98.09 grams. Again, we're going to convert now from our moles of sulfuric acid into our moles of water, which gets us just a little bit closer to solving our equation. So we know that we want to cancel out the moles of sulfuric acid, so we're going to go ahead and put that in the denominator. So it's not going to be 1. 1 mole of H2SO4 is equal to how many moles of water? Okay, how many moles of water do we have? 6, same as up here. Now, how many moles of sulfuric acid do we have? Now we have 3. So we can cancel out our moles of sulfuric acid, and we're now left with moles of hydrogen. Let's go ahead and convert that now. We have to figure out the molar mass so that we're left with just grams. So 1 mole of water, H2O, is, the molar mass is 18.029 grams of water. Again, we got this number, same as this number, by multiplying 2 hydrogen at 1.01 plus 16 oxygen, 1 oxygen at 16, which gives us 18.2 grams. So this gives us 1.102 and a few other numbers, but we have 3 significant figures, so I'm just going to cut it off at 1.10 grams of H2O. So now, whichever compound yields the least amount of product is our limiting reagent. So 1 gram of aluminum hydroxide will only produce 0.693 grams of water, so that's as much water as we can make. So this is going to be our limiting reagent. Aluminum hydroxide is our limiting reagent. Thanks for watching the Classy Chemists, and good luck.